Hey guys, this is Mr. Teen Tutor in the house, and today we're going to be talking about composite functions and how to find them and to find their domains. Here's an example problem for you guys. F of x equals 1 over x plus 2, and g of x equals 4 over x minus 1. So we need to find f of g of x. This also means fog of x, which is what some people like to call it. They mean the same thing, so if that comes up on a test, this simply means that. So don't get confused by that. Now, for those of you who are an Algebra 2 trig or were an Algebra 2 trig, you learned that, or I think most of you learned that you should find the composite function, as in simplify it, and then find its domain. However, for those of you who are in pre-calc, I think most teachers tell you to find the domain first and then find the composite function. So what we're going to do is we're going to find the domain first, because I think by finding the domain we can check that answer with our composite function. It makes more sense that way. So let's find the domain first and follow these steps very carefully. The first thing you need to establish is the domain of the inside function. And what I mean by that is the function on the inside right here, which is g of x. So let's look at the domain of g of x. X cannot equal 1, but it can equal any other number. So keep that in mind. The next thing we need to do is find the domain of the outside function, which is, you guessed it, f of x. Even though there's an f on the outside and no x accompanied with f, it doesn't matter. You look at f of x still. Turns out x cannot equal negative 2, but can equal other numbers. Now, with those two domains right there, we say now that the domain of the inside function also includes the restriction set by the outside function. So in other words, now we're saying that for the domain of the inside function, not only cannot equal 1, but it cannot equal negative 2 either. And then we simply say we set the inside function not equal to negative 2 and then find the x value that doesn't work either. So 4 over x minus 1 cannot equal negative 2. Now you're probably wondering, will the domain include negative 2? No, it won't, because remember, we're trying to see what values of x don't work. We know that 4 over x minus 1 cannot equal negative 2, but that doesn't mean negative 2 is an x value that doesn't work. We need to find what this x value equals, and that will be part of the domain for this composite function along with 1. In fact, you should circle this number because you got to remember that. So let's come over here, and I'm going to write the same thing. So let's cross multiply. Negative 2, I believe. Yes. So negative 2x plus 2 cannot equal 4. Negative 2x cannot equal 2. So x cannot equal negative 1. Which means that the domain of f of g of x is all real numbers except negative 1 and 1. Now some of you like writing that in interval notation, so you'd write it like this. Of course, remember you can't use brackets because it can't equal negative 1 or 1. But that's how you write it in interval notation, that's how you write it in regular words. Now, based on this domain, we're going to simplify and we're going to find what the composite function is, f of g of x. I'm going to erase this, but at the top here I'm going to say that the domain of f of g of x is, like we just said, I'll write it in words, all real numbers except for negative 1 and 1. And once we obtain an answer for our composite function after simplifying it, we will see whether this domain fits what we have, which it should. So f of g of x. Sub in g of x, which is 4 over x minus 1. And then you would sub 4 over x minus 1 into x here. because it's the function of something and you substitute it in there. So now it's 1 over 4 over x minus 1 plus 2. We have a fraction within the fraction, and that's disgusting. Just very annoying. So what we need to do is we need to get rid of this fraction right here. And how do we do that? Let's find a common denominator. Can't talk today for whatever reason. We're going to multiply this by x minus 1. And what do we do to the denominator? We have to do the same thing in the numerator. So let's multiply this out. So we have x minus 1 in the numerator over 4 over x minus 1 times x minus 1. Well, the x minus 1's cancel out, so I'm left with 4 plus 2x minus 2. I distributed the 2 to x minus 1. So now I have x minus 1 over 2x plus 2. And then if we factor this, the denominator, we have x minus 1 over 2 times x plus 1. So now let's look at our domain. We said that x cannot equal -1 or 1. Well, if you look here, the denominator can never equal 0. And if you sub in -1 here, that would be 0. So we know -1 works. Now you're probably thinking that 1's going to definitely work because 1 is this. If this were to be 0, x would be 1. That's in the numerator, no problem. But the truth is, you can't say 1 is not a restriction because 1 was still part of this original problem right here, original function, 4 over x minus 1. Doesn't matter. If you sub in 1, that'll be 0, and that's a problem. So this is correct, and the domain confirms the composite function and vice versa. So that's how you find the domain first and then the composite function. And like I said, some of you find the composite function first and then the domain, which is fine, but I just want to let you know of a new way you can do this to check your answers, which I think is actually very efficient and makes more sense. I hope this video has helped you. If you have any questions about how to solve composite functions, please write on my channel. Thank you.